So let's say we have an object that is dropped from a height z naught, and of course it will hit the ground with some speed, and we want the speed of the object, or the vertical component of the velocity. So we know that we can do this using kinematic equations, and we'll want to see what it looks like using work equals difference in kinetic energy. So from the perspective of the kinematic equations, the vertical component is equal to the initial plus acceleration times time, and the initial is 0. So we have minus g for the acceleration times t. T is the unknown, so that forces us to the position kinematic equation, which says y equals y naught, blah, blah, blah. So the final y is 0. The initial y is z naught. V naught y t, that's 0. V naught y is 0. Again, minus 1/2 gt squared. So we'll get our time from this. We'll plug it into there. It's a two-step process. So our time is 2 z naught over g square root, and Vy therefore has to be minus g times 2 z naught over g square root, which is minus square root of 2g z naught. So that's the vertical component, and the speed of the object is just a positive value here. There's no horizontal component. So if we look at this from the perspective of work equals delta k, then the right-hand side looks like final, which is 1/2 times the mass times the speed squared. And we call it Vy, so let's call it Vy here, minus the initial, but there is no initial because it starts from rest. So delta k looks like that. It's just a final kinetic energy. And the work is, of course, the integral of the force over the distance, and we know that this is just mg times the height, which is z naught in this case, force times distance. That must be positive because the right-hand side is positive, and therefore Vy is, we're going to have to pick positive or negative, and Vy is the component, or the vertical component, and so we'll pick the negative because the down direction is negative given our conventions here. So we get, we multiply by 2, we divide out the mass, we have 2g z naught, then we take the negative square root. And so we end up the same place, but in one line as opposed to two.